Section 3.7 Derivative of inverse function. In this example, we are given f of x equals x cubed plus x minus 2, and we're informed that g is its inverse. Our task is to find the derivative of the inverse, g prime of 0. In order to do so, we need to recall the formula for the derivative for the inverse function. So g prime of y will equal 1 over f prime of x. Now, you need to understand the relationship between x and y. Okay, so what is that? Well, if f and g are inverse function, okay, because they're inverse function, what it's telling you is that if the point x comma y is on the graph of f, then the point y comma x is on the graph of g. Now, this concept we learned from pre-calculus. So what it's telling us is that, okay, so if the point x comma 0 is on the graph of f, then 0 comma x is on the graph of g. And in this case, this 0 right here is the y value in f. So what the first thing we need to do is find out, okay, we don't know anything about g, but we know something about f. And the reason we do not know anything about g is because f is a third degree polynomial. We cannot solve, most of the time we cannot literally solve a third degree polynomial. So what we do is, okay, we realize, okay, the question is saying what happened when y is 0. And we need to find out the x value such that y equals 0. So in this case, we need to set x cubed plus x minus 2 equals to the value that is in the question is 0, okay? So now, this again is a third degree polynomial, and we solved something like this in pre-calculus. And there are a few techniques you can solve it, okay? Number one is you graph the function. You graph this function and find out where the x-intercept is. So when is the function equal 0? So that is one way, and you can trace using the trace function in your graphing calculator. You will be able to find out an estimate of x. That's first. Number two, okay, is factoring. Okay, we know there are third degree polynomials that can be factored, but there are some that are not possible to be factored. But factoring is one of the techniques we can use. And the last technique is what you call the rational roots theorem. And again, we have to refer back to the pre-calculus. But in our case, okay, I can show you, there will be another method, but it's not very scientific. And people call it eyeball method. Now, what is it is that, okay, you just substitute some value. Each simple value to substitute are, okay, x equals 0, x equals -1, x equals 1, x equals 2, x equals -2. You try those values and see if any of those work. But that's not very scientific. The best way you would be factoring. And I'm going to present how to factor this polynomial. So, but if you try the eyeball or the rational root theorem, you realize when x equals 1, okay, 1 cubed plus 1 minus 2 is exactly 0. So then you'll be able to find out x here equals 1. But outside of that, I'm going to show you how. Okay, so think about it. When we learn factoring, we only know a few formula to factor. In particular, when we have x cubed, right? When we have a cube. So we have a cubed minus b cubed equal, how do you factor that? A minus b times a squared plus ab plus b squared. Okay, so that is a particular formula. But if we have a plus, okay, here became plus and there became minus. So refer back to those formulas. So in our case, we need to have a b cubed, right? So what's a natural number that you can think of? Okay, it's x cubed minus 1. Okay, because we have minus 2. And if we do that, you take a look, x minus 1 equals 0. What happened is that we break minus 2 into minus 1 minus 1. Okay, so that adds up to negative 2. But if we do so, what happened is that we will be able to apply the formula, the difference of cube formula. So you get x minus 1, x squared plus x plus 1. Now you plus x minus 1. Okay? So now you see common factor, x minus 1. And what happened here is x minus 1 times 1, right? So you add 1 to this expression, you will get x squared plus x plus 2 equals 0. Now you'll be able to solve this equation. Well, when when the product of two expressions equals 0, it has to be either x minus 1 equals 0 or x squared plus x plus 2 equals 0. And then you can apply the quadratic formula. You realize there's no solution here, no real solution. But here x equals 1 is a solution. And then you'll be able to verify that the point 1, 0 is on the graph of f. Therefore, the point 0, 1 is on the graph of G, and G prime of 0 corresponds to 1 over f prime of 1. Okay, so now what we do is evaluate our G prime of 0. Accordingly, is 1 over f prime of 1. Now in that case, it's 1 over, okay, what is f prime? So f prime is just a polynomial, so it's 3x squared plus 1. So what you do is you plug in 1, right? 3 times 1 squared plus 1. So just 1 over 4. Okay, or you can write down as 0.25. So that is a solution to this problem.